So we will start to make the codes. So as you can see, the make will contain a root node and the value which have to be. So if root is equal to null, so we have come across a desired position here. Then in that position, first of all, we have to make a constructor which will contain a value. So this dot value will contain the value, and leftmost child will be null, rightmost child will be null at this moment. So at this moment we would be making a new node in the heap. So we will provide in the heap with the value given. Then we will return its address. Okay. Then so here I will be writing at which node we have to go, as I was telling you in the graph, the root. Like we are in the root node and we have gotten the value 4 to be put on this tree. So we would checking if 4 is less than the parent value. No. So we will not go to the left part. If 4 is greater than 1, yeah. So we will go to the right part. So here I will writing the same thing. If root order value is greater, and at this moment I would be going to the right part. Then I will be going to the right part and we will be writing root order right, and I will be putting the root. Else I will be going to the ref part, and then I would be making left order value, and then I will be returning my root. So this thing would make my binary tree. So I will try and run using a array. So basically I will again 1 2 3 4 5. So I same thing I will given 1 2 3 4 5. Then there isn't any tree made, so then our root would be null at this moment. So one will be written. So one root will be there, and its leftmost and rightmost would be null. Then I would iterate on 2. So at this moment root is not equal to this moment my root is 1. So 1 is not null. Then I would go to the 20th line. If the values get, yeah, the values get. So I would be going to the uh, rightmost point. And whenever I go to the rightmost point, the root is null at this moment. So I will make a new node and would return the address of it to the 1. So root order right will get the address, and then it also will returning the address to the calling function. So I would make a similarly it would go like this. 1 will be called to 2, 2 will be called to 3. So at this type our binary tree would. So it would be called, so it would be called, we would try to tell you. So it would be a root. So then suppose we have value, let's say 2, which has to be inserted. So root is equal to make root order 2. So I'm putting the 2 in the value root. Then I will put in the 3 here, make root order 3. So root will be unique. The root will be the node from which I can go to every node. Like it doesn't contain its parent. You can tell, like in this graph, root is a node which doesn't contain any parent, as you can see. Similarly, that thing is there. So and the second point is, how would you iterate on a binary search? So we have built a binary tree. Then we got to know how we'll be iterating on a binary tree. For this, there are multiple methods. The first method is called in order traversal. The second method is called post order traversal. The third method is got pre order traversal. So what is the difference between in order, post order, pre order? So the difference is that the difference is the based on the node position uh, in the search point in searching. So in the in order so let's say in the in order, I will go to the first leftmost position. Then I will get the value of the node, and then after that I will be going to the rightmost position. In the post method, I will go to the leftmost, then I would be going to the rightmost, then I would iterate, get the post, and will return from the node. In the pre, I will get the node, then I will get the leftmost, and then after I will get the rightmost. So this is the difference between this. So I will write it in order, post order in the search in my tree. So this is my root node. So I will start from the root point and we start iterating using in order. So I will start from in order. So what in order tells, we have to first traverse to the leftmost point first, leftmost all the leftmost nodes. I will go to the leftmost node in the 30. 30 will go to the leftmost node, 25. 25 go to the leftmost, so it is a null. Then it will revert back to the 25. Yeah. So from the leftmost, I have come to the middle. है ना? What it say? Go to the left, then take the value of the node offer, then go to the right. So yes, so in error I will get the value of 25. Then I will iterate on the rightmost, and then that one doesn't contain, so I will come here, then I will revert back. So 30 has come in the middle, then 30, then 35, then 45. It will go there, then it will go here, then it will go here, then it will go, yeah, it is middle. So whatever is middle, you can see, then it will go 50, yeah, 50, then 60, and then 60 would go there, and it will be returned back. So from this, as you can see, from this you can see that it is sorted in the increasing order. So in the binary search tree, when we will use in order traversal, then we get a sorted in the then we will get the values of the binary search tree in the sorted manner. How would we writing it? We will get to know. So we will use an in order traversal here. So we will get the root value first, and then we will check if If root is equal to null, then we will return root. Else we will go first in the in order. We will first iterate traverse on the leftmost node, then we will get the values of our var, then we will iterate on my rightmost node. So this thing would give me the in order travels. Similar is the code for the post order. The only change we have to put here is that we have to put our here only post order tables. So here, as you can see, so okay, sorry for the interruption. I was seeing the recording whether it's starting or not. So here, as you can see, we are going in the left mode direction, and then after we are going in the right mode direction, and after that we are getting the value. So this is post order, and similarly that's the case in the pre-order also. So you can see how to write it. So this is the searching method, so how to search elements in a binary search tree. So the first thing which a question arises, how to check whether a binary tree is a binary search tree. How could we check it? Let's suppose you have given a binary tree like this, and you have been told to check whether it is a binary search tree or not. So this is a standard question of the binary search tree. How to answer this question? So there are multiple approaches which are there to solve this question. So first approach which come in every person mind is a brute force approach. So in the brute force approach, what we can do is first we will see we will get a node from the binary search binary tree, and using that node we will check whether all the values in the left part are less than from it, and all the value the right part are less than from it or greater than from it. So we will do for every node which are there in the binary tree. So there are around n nodes in the binary tree. For every n nodes we will do these iterations. So for to do the so it would be around n square. So we will go to every n nodes. So it would be n square iterations. So this is not a good time complexity out there. So if we have to write this thing, then so what we can do is we can use any searching method, and any searching method, and using that searching method we will get a node. So from that node I will again uh, uh, again use a searching method to check if the leftmost and rightmost are less than from it, are not less than or greater than from it. But this is not an efficient way to write this. So what would be the efficient way to do this? So first efficient way is we can see now we can see one thing, that every node should be in a starting or ending value. Like 40 should be between a starting or ending value. Like you can see 40 should be, if you give it minus infinity, so it would be a base case. So 30 should be in a range, like it should not be greater than 40. It should be greater than 40 and less than, not be greater than 40. But if you see 35, it should not be greater than 40, but it should be less than, sorry, it should not be greater than 40, but it should be greater than 30. So this thing comes in a starting or ending line. So to do this, uh, we can have, so to do this thing, we can use check whether it is a BHT. So the BHT would contain a root node. If we are come at so we will write our base case first. So every root would be, if we have come up to a root values, and then we have to provide a max with the max point for that root, and what is the min value for that. So we will write, if root, if we have come up to a root, the root value, so max would be, should be greater than, and root should be, greater than or equal to min. This is there, then bool, we will go to left. So, we will go to the left point, and when we will go to the left point, then we have to change our range, max and min range. So what would be changing here? So whenever we will go to the leftmost point, which thing will change? Max will change or min will change? Which thing will change? So whenever we will go to the, so what thing will be changed is the 40. So all the numbers would be smaller than, should be smaller than 40. So the thing which be changing is the maximum value. What will be the maximum value up to now? So to write this, so the thing which be changing is basically uh, like if we are going here, then if this is min, and if there is max, then uh, this should be maximum. So what will be the maximum value? 40. Okay. So max value will be changing. So we have to write max of mx would be there, and root order value, and min should be similar. Similarly, else return with false. Like if doesn't, if this thing is not correct, then we have to put false. And then when we are going to the right position, we have to check whether our BHT is less than or, so when we will going in the rightmost point, then we have to change whether the number is less than the minimum number or not. So as we are discussing, when we are going to the rightmost, then the minimum should be greater than 40 but less than 50. So I will put, so what we are putting here, where yeah, here. So the minimum should be so maximum would be similar, then the minimum would be maximum of Yemen. What would be the minimum to the Yemen root order, right? Root order value, sorry. Then they both should be true in order to be a left and right. So the both should be true. So if we call it bool ex equal whether BHT which I have made, so for minus infinity minus I will do into max comma in max. So this would give me whether my BHT is whether my binary tree is a BHT or not. So this code will give me answer about it. So uh, so this is the code for checking whether my BHT whether my binary tree is a BHT or not. Then so the time complexity for it would be only order of n only, as we only would be iterating all the nodes which are there in the binary tree. So as you can see, we have optimized our code to from n squared to n at this moment. So this is the most efficient method out there to find whether a binary tree is a binary search tree or not. Then the next question which comes out there, or the standard question, is what is the minimum and maximum value in a binary search tree? So at a binary search tree, where would we would be getting the minimum value? In the leaf node, in the left to leftmost leaf node. And how and where I would be getting the maximum value? In the rightmost leaf node. So so in here, if we have to find in this binary tree, if I have to find the where the minimum number, so but which is the leftmost leaf node here? 25. So in the rightmost point, in the rightmost node, which is the rightmost leaf node? 60. So as you can as you can observe that we only have to go to the leftmost point only in order leftmost nodes. So how I would be going to the leftmost leaf node? So for that, what I can do is I can use a while loop, and I will iterate go to the leftmost node. So to write this thing, first I have to get the root node while root order left not equal to null. Root is equal to root order left. So this code will traverse me to the rightmost leaf node, and after that I will be returning the rightmost node. So this thing, the similar thing I have to write in the for the rightmost point. How to find the rightmost leaf node? So we only have to change the right. Then it would be going to the rightmost point here. After that, when we so after that when we come out of the while loop, we were in our rightmost leaf node. So they both will give me the leftmost and the rightmost leaf node in my binary tree which I have made. So you can write like this, root. So that's all for um, binary search tree. So we have covered all the topics, like we have covered most of the topics as we have discussed how to construct a binary search tree, how to search in a binary search tree, how to check whether a binary tree is a binary search tree, how to find the maximum and minimum value in a binary search tree. So that's all. So I would be ending my uh, tutorial here.